So dy dx is the same as f of x. So we can say y is equal to f of x. So our f of x, this one is same as f bar x. So our f of x in that equation is equal to sine 2x plus 3. Now, this is the formula that we are going to use when solving this kind of equation using first principle. First, we have f prime x, which is the same as dy dx is equal to, so we will introduce limit when h is approaching 0, then where there is x, we take x plus h minus f of x all over h. Then from there, so our f of x is equal to sine of 2x plus h. And now, when there is x, you replace this function here. So for example here, I have sine into 2 into x plus h plus 3. So all of this is what I'm going to pick and place there, such that my f of x prime all dy dx is going to be, now limit, don't forget to write the limit, because that is what is directing you. H is approaching 0 at, now, sine of 2, where there is x, like here we have x somewhere here. So where there is this x, I will place this, x plus h plus 3 minus f of x, and our f of x is all of this, minus sine of 2x plus h, and everything all over h. Then, now if you look at this equation, then you can try to open the bracket such that we'll have our f of x when the limit h is approaching 0. I will have sine into 2x plus 2h plus 3 minus sine into 2x plus 3 all over h. And now, when you look at this function here, we are going to relate it to the trigonometric equation, which says that when you have sine A minus sine B, if you look at your log table, you will find that it means we have cos 2 cos A plus B over 2 sine of over 2. Now in your log table, you will find A is written as alpha and this one is beta. So we are going to start by let 2x plus 2h plus 3 to be our A, and 2x plus 3 to be our B. So where there is this is going to be equal to this one here. Where there is B, tutaeka I, where there is A, tutaeka I, using this formula. So let's bring it back. So limit when h is approaching 0. So remember we have just changed this one to all of these because they relate. It's the same thing that we are doing here. So we'll have 2 cos 2x plus 2 plus b. So you'll have to add with b, and b is this one, plus 2x plus 3. Everything over 2. Sine hii hapa 2x plus 2h plus 3 plus minus 2x plus 3. All of these you put over 2. Write your h below there. So we can try to collect the like terms here because we have 2x, we also have 2x this other side, such that f of x is the limit when h is approaching 0 to be 2 cos of 2x plus 2h, that is 4x, plus 2h, 3 plus 3, 6, over 2, sine of, now 2x minus 2x, that is 0, then 3 minus 3 is also 0, then we have 2h there to be 2h over 2, and everything all over h. So at this point when you reach here, of course you will start to divide everything because all of them are divisible of 2. So utangalia hapa 2 inaenda 1, 2 inaenda hapo, it's going there 1, 2 times, 2 goes here 1, 2 goes here 1, 2 goes here 1, 2 goes here 3, such that what we have there is now limit when h is approaching 0 to be 2 cos of 2x plus h plus 3 sine of 2 will cancel h over h. Now there's also a formula which says when you have sine of x over x is equal to 1. So when we have our sine h over h, this h it will be 1. So when there is sine h, it replace the 1 such that t na hii will cancel each other. So hapa tutakuwa na 1. So 1, if you multiply with all of this, you will get that our limit now h is approaching 0 to be 2 cos of 2x, where there is h plus h plus 3. Now you are going to use the limit. So you will say that if h is equal to 0, so when there is h, you will replace with 0, such that now your final answer will be 2 cos of 2x plus 0 plus 3. So the differential of that, which is dy dx, will be 2 cos of 2x plus 3. That is our answer.